So in terms of ether synthesis, there are a variety of reactions you can use to actually synthesize ethers. Among them is, for example, the acid-catalyzed condensation of alcohols. You can also have the acid-catalyzed addition of alcohols to alkenes. We're not going to talk about those reactions. The one reaction that we're concerned about is going to be the Williamson ether synthesis. And the Williamson ether synthesis is a really simple reaction mechanism. It's just an SN2 mechanism of an alkoxide nucleophile on a primary or a methyl halide. So recall, you can form an alkoxide from an alcohol by treating it with a strong base. So if you take, for example, here you have an ethoxide anion. If you treat ethanol with sodium amide, NaNH2, the NH2 anion is going to abstract the hydrogen from this hydroxyl group and that'll leave behind an alkoxide anion, in this case the ethoxide anion. This ethoxide anion can serve as a nucleophile for relatively unsubstituted alkyl halides. But recall, we were talking about these a little bit earlier on in the semester. These guys are also really, really strong bases. The pKa of alcohols, ethanol specifically, is somewhere around 16. So those are relatively weak acids, and as such, the conjugate bases are strong bases. So whenever you use secondary and tertiary alkyl halides, you're going to get predominantly the elimination products. All right, so in this case, your substrate for the SN2 reaction is going to be a primary or a methyl halide. And you can get relatively complex ethers this way, but you're going to have to do a little bit of logical deduction to figure out exactly what alcohol you want to use to synthesize the alkoxide anion and what alkyl halide you're going to use as the SN2 substrate. So, for example, in the formation here of tert-butyl methyl ether, you can probably guess that you can't use a tert-butyl halide just because tert-butyl halide would be highly substituted and you're going to have competing elimination reaction. So in this case, you're going to use tert-butanol as a starting substrate, treat that with a strong base, end up forming a tert-butoxide anion, and then that tert-butoxide anion can serve as a nucleophile for an SN2 reaction with methyl bromide, for example, and that'll give you tert-butyl methyl ether. Similarly over here, an isopropyl halide probably wouldn't be a very good substrate for SN2 just because it's relatively substituted and you're going to get a competing elimination reaction. So you're going to start off with a isopropoxide anion, and here, since you have an ethyl group as the second R group, your substrate for the SN2 reaction can be ethyl bromide.